All right, guys, let's look at this next example. Fritz, all we have to do, if we want to figure out which ones are bigger, or from least to greatest, is change them all to scientific notation and look at the exponent of the 10. That should help us out. If they're the same, then we compare the other number, right? But let's look at this first one. I don't need to change this one at all. It's already in scientific notation. 3.9 times 10 to the 6. Good. But what about this next one? Let's change it. 1, 2, 3, 4, 5, 6. Okay, tell me what to write. 3.8 times 10 to the 6th. Excellent. Oh, okay, now they are going to make us work for it. Okay, 4.2 times 10 to the 5th. Which one's the smallest, Fritz? 4.2 times 10 to the 5th is the smallest because it has the smallest exponent of 10. Good. What's the next one, please? Trigo. 3.8 times 10 to the 6th. Right? It has the same exponent as this one, but the number, the units number in front is smaller. Well done. Thank you, Trigo. And so our last one, Cole, is of course what? Don't make me wait for it. 3.9 times 10 to the 6th. Well done. Does that make sense? Change them all to scientific notation. Look at their exponents of 10. That should do it. But if that doesn't, if they're the same, then we look at the units in front of the 10, the power of 10. Yeah, Liam.
Couldn't you, I find it's easier to look at if I just write like 42 times 10 to the 4.
Now, Liam is saying, why don't we move this back one and then change this to a 4? And then what? Okay. Now let me say something. This would not be correct if you were writing it in scientific notation. Because in scientific notation, the number in the front has to be between 1 and 10. It cannot be 10. It has to be less than 10. It can be 1, but it has to be less than 10. All right? Good job, guys. Let's look at the last example before I have to let you go.